as usual, today again we have a problem of CSIR-NET, and today we are going to discuss the problem of December 2012 cycle. It's a problem of 3 marks. As you know that CSIR asks question for 2 marks, 3 marks and 4.75 marks. It's problem of 3 marks means it's a MCQ problem. You have given the 4 options, and out of these 4 any one will be correct. As you may look here that I have already clicked the answer D, that is 0 is the correct option here. But let's see what's the logic behind the appropriate steps which must be taken during the solution. So let's discuss how we will approach the solution and what are the standard results properties through which we will prove them logically that answer D is correct. Okay, so let's start. I'm reading the question for you, then we will proceed the solution, and in between the solution we will mark all those standard results which will be useful for future reference. When we will deal such problems in future, then these standard properties will be useful there. Okay, so I'm reading problem for you. Problem is, let n be a positive integer and let mn over r. This notation is sufficient to recall you that we are going to discuss about the matrices space over real field, a space where we will deal with the n cross n matrices over the real field. I think if you haven't clicked this video and you are watching it, then you will be aware with this mn over r space means matrices space over real field. So we have the to assume a mn over r space, which in language has been written here for clarification that it's the space of all n cross n real matrices. And now if T such that from MNR means space of n cross n matrices over real field to again space of real matrices, T is a linear transformation such that it's defined in a way that T will take all the n cross n real matrices to the 0 matrix. Okay, it's very interesting. Whenever A belongs to M and R means if you will take any n cross n real matrix, then this particular transformation is going to map it on 0. Okay, so here is a key word of the problem, that is A belongs to M and R is symmetric or is skew symmetric. Means there is a restriction for the choice of such a matrices which will map to 0 by a T linear transformation. Those matrices should be symmetric or skew symmetric. Means this transformation will map all those matrices which belongs to M and R means n cross n real matrices, but there is another restriction, all those A must be either symmetric or skew symmetric. Means this transformation will map all those matrices to 0 which either are symmetric or skew symmetric. Okay, then what is the question? Question is, then the rank of T is, means you have a space that is matrices space over real field, then you have given a transformation, a particular transformation which is defined as a special transformation which is going to map all the symmetric and skew symmetric matrices to the 0 element. Now the question is what? The question is about the rank of T, means what will be the rank for this particular linear transformation. I think now till now it's clear that what's the theme for this question, about which topic CSIR is trying to check your knowledge. They are trying to know whether you have enough information regarding this M and R space means n space of n cross n real matrices, and then they are checking your knowledge a little bit about linear transformation and rank of the matrices. So let's think how we will approach this problem. When we are dealing with such type of problems like we have to talk about a matrix n cross n real matrix, and then we know that this transformation is going to map all those matrices which are symmetric or skew symmetric to 0. Then when these two words symmetric or skew symmetric are appearing together, then there must flash a theorem, a standard result of matrix theory, I have already written it, so I will read from here. This result, you must recall this result whenever you read anywhere, whenever you read the words symmetric and skew symmetric collectively, then you must have to recall this theorem, that every square matrix X can be represented as the sum of symmetric and skew symmetric matrix. I think it's the major exercise problem for your BSc part 1 in linear algebra, when you all have studied about this type of questions, about these type of questions, that you have given a matrix X and then you have to break it in symmetric and skew symmetric parts. Then you have been already used this type of formula, that 1 by 2x plus x transpose, this is your symmetric part, and another part 1 by 2x minus x transpose is your skew symmetric part, and whenever you will add these two parts you will get simply x. Means we have splitted here x into two parts, and the first part is first part all is well about the definition of symmetric matrix, means this is symmetric part and this is skew symmetric part. You know about this result. So whenever you read anywhere about the symmetric and skew symmetric together, and you have to deal with any A, means any n cross n square matrix, then you must have to recall this result, that for any matrix A you can represent it, you can split it into parts, symmetric and skew symmetric. And what's about this special linear transformation, it will map all those matrices which are either symmetric or skew symmetric to 0. And you know about the basic definition of linear transformation. What's it? You know that if T is a linear transformation from a linear space V over F to another linear space W over F, then this T will be a linear transformation if T of lambda u plus v, where lambda is your scalar, it will come from field, and u and v are the vectors, these are elements of your V set, means vector space. Okay, so this T will be a linear transformation if it's holding following property: T of lambda u plus v, you are free to split it in like lambda dot T of u plus T of v. If your T is holding this property, then it's linear transformation. Okay, means your linear transformation allows to split the input. Okay, so here let's come back to our problem. We have a linear transformation T which is mapping to all the matrices and cross n matrices which are either symmetric or skew symmetric to the 0 element. So let's take any general matrix X. Let's consider any X which belongs to your MNR, means n cross n real matrices space, means it's any general matrix. Then what you can do, you can break it into two parts. The first will be symmetric part, another one will be the skew symmetric part. I have already written the solution, so I'm going to explain it from there. We have the calculation already, I have written it here. So we have this result that any square matrix can be break down into two parts. The first one is symmetric, another one is skew symmetric part. So if I'm considering any matrix A from MNR space, then I can write it here as T of A equal to T of what? I will split this A in two parts, 1 by 2 A plus A transpose plus 1 by 2 A minus A transpose. And you all know that the first part is what? It's symmetric part and it's skew symmetric part, and our given linear transformation was mapping to all symmetric and skew symmetric matrices to the 0. Okay, so if T is a linear transformation, so 1 by 2 I can take it out. Okay, so 1 by 2 is here, and when T will operate on A plus A transpose, then A plus A transpose is a symmetric part. It's a symmetric matrix, you know it very well. As per the definition of symmetric matrix, A is a symmetric matrix if A transpose equal to A. And if you will take the transpose for this A plus A transpose, consider this is a single matrix, and now if you will take transpose of it, then you will get A transpose plus A transpose ka transpose, you will get it A. Okay, so when you are taking transpose for this matrix A plus A transpose, then you are getting again the same matrix, means this A plus A transpose is symmetric matrix, and it's easy to verify that this A minus A transpose is again skew symmetric matrix. So your T will map to all those matrices which are either skew symmetric or symmetric to 0. So T will map to this part A plus A transpose to the 0, and again in the second part A minus A transpose are skew symmetric matrix, and your T will map it to where? It will map it to 0. So after calculation, what you are getting that if you will consider any element of this matrix space, then your T is going to map it to the 0. Means this transformation is nothing, it's actually the 0 map. It's actually what? It's the 0 map, which is mapping to all the elements of your space to 0 element. Actually it's not directly written in your problem. They have told you that this is mapping to all symmetric and skew symmetric matrices to 0, but you know it very well that any matrix of any element of this space can be written as the sum of symmetric and skew symmetric part, and if this T is mapping to symmetric and skew symmetric parts to 0, then overall this T will map all the elements of this space to the 0. Means this T is nothing, it's actually 0 mapping. This T, this given linear transformation is 0 mapping, and you know it very well. It's a standard result that the rank for 0 matrix is 0, because rank is the number of elements which are going to map another Li set. Okay, and you know about the 0 map, it will map all the elements of the space to the single element of the codomain space, that is 0. So rank for 0 mapping will be 0, and in this way we are at the stage when we can say that the option D is correct option. Okay, so it was the question of December 2012 cycle in 3 marks, and actually in the whole questions, yes, I was trying to check your knowledge regarding this matrices space, a little bit information about linear transformation, and a little bit information about the rank for 0 map. It's a standard result, I think. So okay, we will meet soon in another video with a difficult problem of CSIR-NET, and we will do there again a detailed analysis as we have done today. So okay, bye, take care, revise the questions and try to crack the problems itself. Okay, bye.